All right. So in the last video, we stopped at the we said that we would be executing this, and we would be wait until this execution gets completed, and we saw that it executed a whole heap long, and it took in almost like 2 minutes or 4 minutes for me to get executed entirely. So after this, what we will be doing is, as I said, that the scores list is nothing but a dictionary inside. So we are storing a dictionary inside a list. So we will be unzipping that dictionary into a pandas data frame, and we'll see what are the results. And we see over here that random forest is giving like 0.0 best score as to be this. Neg mean squared error means you can ignore this minus, and you can see that 0.075 is the error which it got. So that means that is a very low error. That indicates, when the error is low, that indicates the accuracy or the prediction rate is high. So I think so this is giving a good insight over here. So if we just try to see, we'll be using this random forest classifier object. Random forest classifier object, we will be using this, and we will be placing it over here, and we will see what kind of results we are getting. Okay, so let me just, for safer side, what I will do is, we will just copy this and we will just paste it over here, so that if in case we are not getting good results, we can use this, because this already this configuration which randomly I chose already gave me 88% result. So if that is giving me 88% result, and this is giving me like 70% or more or less result, I will reject it, right? So I will just paste it over here, and this one is nothing but the one which I copied from here. So for safer side, I'll copy it again, copy, and then I'll paste, and then I'll just press shift enter, and this will take a little bit time. Yep. So we see that there is no change. Basically, it is also giving 88.4% result only. So this is giving a little bit better result, 88.4024, than the other one. Okay, the other one, I think so, gave us something nearly to be 88.24 something. So the same kind of configuration has been detected by our hyperparameter tuning also. So we will be using this random forest model, and we will be trying to predict on the entire data set. Now what do I mean by this entire data set? Let's, if we just see train, if I just hit train over here, we get this, right? So now in this train, what I need is, I need this train to be in a numpy array, because this RF object, if I try to predict, this is taking a numpy array, because xtest is a numpy array. So I'll be converting this train into a numpy array. So test train is equals to np.array train, and then for I in range, len of test train. If you just try to observe xtest dataset, how xtest numpy array looks like. Xtest is basically this thing only. It's a pandas data frame. If you unzip it, it becomes a numpy array, and it will look something like this. Okay, it will look something like this over here. Just a minute, I'll just show. It will look something like this. This is the outer list, this is the inner list, and inside the inner list you will be having values. So for what, so in test train is already a numpy array. So in that numpy array, I am adding one more. So I'm adding this list in order to kind of make things work possible. So I'll say rf.predict the numpy array I'm passing, and then I will hit on shift enter, and this will be basically predicting on all these 1302 rows. So this will take a little bit time, because it is running the entire code on all these 1302 rows. So basically what I did is, all these 38 columns are there now, 1302 into 38. I converted this entire data frame into a numpy array, and then this numpy array I passed as an I ran a for loop into it, that is this for I in range len of test train, and I passed each and every index, that is nothing but train of 0. If you do train.iloc of 0, if you do, what you get? You will get the first index. Okay, you will get the first index value basically if you do train.iloc.0. Yes, this will take a time, because over here this cell is already running, and I did some whenever this is executing, I shouldn't do this practice, because this might affect the execution also. So I'll just cut this cell, that's not required, that's not important. Let this execution get done completely, and we are good to go now. We are good to go then. So this will take a little bit time, and then yeah, so this will take a little bit time, because 1302 rows are already 1302 rows at once are being sent to it. So this will not take that much time, I think. Hmm. Yeah, so we see that we get this numpy arrays. Now I will let me just revise a little bit when I talked previously about the transformation which I did, right? So you might be thinking that, hey, but the prices must be like 71,000 or so now, why it is like 10 or 20 or something like that? Yes, I'll answer that question in this way. So in some of the video, in the previous few videos, I said that the 75,000 thing is in the left skewed distribution, but 11 point something is equivalent of this left skewed distribution in the centrally skewed distribution, right? So the same kind of ideology will be applying over here. So if you just observe, if I do np.exp of this 11.175, I am getting 71.7337 71,378, which is what I need, right? So I'll be applying the same kind of logic here as well. So what I'll be doing is, this is the numpy array. I'll say np.exp predicted of I of 0 for I in range len of predicted. This is array, right? So in array, this is the entire part. So how to extract this entire part? Array in predicted of I is basically, if I is equals to 0, that means this. Of 0 means this value only, 11.13800033. Okay, so for every index I'm extracting the first value, as this is a 2D list, a list inside a list inside a list. That is the meaning of this. For I in range len of predicted. If I click on this, I'll get the answer. Okay, and then I'll store that answer over here. Df of predicted price is equals to np.array of answer. So I get the np of array of answers over here. Now what I will do, now I will compare the answers. Okay, so sn.dispplot df of price is equals to false. I just need to see whether the distributions are matching or not. If I do this, I see this is not a very good result, because I can see that this predicted price, it is not even reaching this 35k over here, right? It is just stopping by 3,50,000. It's not even reaching this tail end. It is just truncating down to 1,50,000, and by max it is going till 1.5. So 1.5 into 10 raised to power minus 5. So I don't think so this RF model, which is like CCP alpha equals to this, is a good choice. Instead of instead of using 1077 estimators, I'll be using this algorithm. Let us random forest CCP is equals to this thing, and I'll see what I'll get. So random forest version 2. So random forest regressor version 2, where estimators are only 100. So if I go with this 100 estimators, let's see what happens. I get an accuracy of 88.7. There I was getting an accuracy of 88.4. Here I am getting an accuracy of 88.7. So I think so random forest regressor version 2 is working good, and we'll see about the execution of this. Let's start the execution, and I'll pause my video over here, because this will take a little bit time, as I said. So once this is executed, I'll continue in the next video then.